Good afternoon. My name is Shanti Wilson and I am one of the SAPICS directors. And today I'm here to talk to you about operations and the role of operations in supply chain management. I apologize upfront for not being present for the webinar that was originally scheduled, but unfortunately due to load shedding, I was not able to be there. I am going to share my screen with you and take you through the material now. Okay, so today's talk is about manufacturing and resource control. And this is a workshop that has been developed by BizCo. So today I am just going to take you through a small snippet of what is in progress on this workshop. It's just a taste. The real workshop and the material is available from BizCo. And obviously there's a lot more time required to go through this material. So I urge you all to make sure that you get a hold of this workshop, register, and you will learn so much. The first thing we need to understand from a manufacturing and resource control perspective, as all your business functions are interlinked. Sales and marketing, logistics, and production all work together to make your business work. So from a sales and marketing perspective, it's important to understand what does our business sell? Who are our customers and how are we selling to them? Because without our customer, we have no business. From a production perspective, we have to understand what does our business make? How do we make it? And what do we need to make it? This is the concept of what the product is. So we need customers and we need a product in order to have a business. Linked to all of this is the concept of logistics and stock management. This defines how we store our stock, how we distribute our products, and where we buy our raw materials from. And all these different things interlink, because without a customer, a product is meaningless. Without a product, you have no customer. And without the supply chain making sure that the product moves from raw materials through production to the customer, nothing happens. So production control requires a problem-solving mindset. A big part of your role, if you're involved in production, is defining and investigating problems, generating possible solutions using problem-solving techniques, understanding the data or the statistics behind the process, and evaluating all possible solutions. A structured approach to problem solving and the ability to solve problems is a key requirement for a career in manufacturing and resource control. The reasons we have inventory are also important. We need to have inventory to support sales. And in many instances, what I've seen in clients is that they keep too much of inventory and they have too much and they're not selling at all. But it becomes a safety net because there's a safety in knowing that the warehouse is full. There's safety in knowing that we have product to sell. The challenge as a supply chain practitioner is balancing the requirement for as little inventory as possible, which keeps the accountants happy, and as much inventory as possible, which keeps marketing happy. We have to have a balance between, and that has to be linked to the demand forecast and the demand sales. So the elements of inventory, as I mentioned, are keeping inventory investment at a minimum, because money that is invested in inventory cannot earn interest. You could be getting 5% return on investment in the bank. But you also need enough inventory to meet all your customer requirements and to ensure a consistent and constant supply of the right stock into manufacturing so that you can continue to meet those requirements. Everything is interlinked. From a manufacturing perspective, the inventory we're talking about is the raw materials. So those could be chemicals, those could be packaging, those could be ingredients, depending on the type of product you're manufacturing. It could be components, so it could be partially assembled goods that you will use in your manufacturing process. It could be consumables. Consumables will be things that you use on a continuous basis, but it's not that you allocate one item per product. And lastly, it could be spare parts, parts that are used to keep your machinery and equipment going. So if I was to think of a brewery, typical raw materials for a brewery would be things like the yeast, the bottle, the label. Whereas the components, perhaps you would look at cars, where you might need an air conditioning system, you might need seats, you might need seat belts, and you might need airbags within those seats. Those are all components of the vehicle. Going back to the brewing or in the brewing example, consumables would be things like glue that gets stuck onto the label, which goes into the bottle. Consumables in the automotive industry might be things like paint or paint colorants. Spare parts for both would be things that we use to make machinery work. It's important to remember that inventory has value and it costs us money. Because if I was to take 100,000 Rand and invest it in stock, I end up spending that money in warehousing, I spend money in keeping it safe, security, I spend money in a variety of ways to make sure that working capital is looked after. If I take that same inventory and put it into a bank, so instead of buying the stock, I put that money in a bank, I earn capital, I earn money back. So it is really, really important that you don't waste your inventory, that you manage the levels carefully, and you avoid excess, obsolete, or surplus inventory. Inventory management, as I keep telling you, is a balancing act. So, how do we make sure we balance supply and the sales? Because at the end of the day, there's a process that needs to pull together the supply of product, the production process, and the sales process. And this process is the sales and operations planning process. The aim is to make sure you're delivering high levels of customer service, so you want your on-time in full deliveries to be high. To do that successfully, you need to involve all functions of the business, your sales team, your production team, your new product development teams. You need to understand your inventory levels. You need to understand your cash flow considerations. And you also need to understand the seasonality of your demand. So, for example, in the beverage industry, there's always a peak over the Easter weekend and over the Christmas season when people buy more drinks. These things need to be put on top of the sales projections to make sure your demand forecast is accurate. You also need to understand the product requirements, because as customers change, as consumers' needs change, so your product will need to change. For example, when Savannah first came out, it was just a good old-fashioned cider. Now you get Savannah lime flavored, you get Savannah that is non-alcoholic, and you get a range of different Savannah flavors because the customer need has evolved. And that's where sales and operations planning comes in, is where you look at the projected demand from your customer, the supply, what you are able to supply that customer, and how you're going to get it there through the supply chain. To be honest, sales and operations planning is a whole lecture in itself. So I suggest if this is something that interests you, you start doing your research and perhaps register for this course. The production scheduling environment is also part of the manufacturing and resource control, because this is about the planning and control of the actual production in the manufacturing plant. And you need to have planning horizons. For example, the next week might be a fixed plan, no changes are allowed. The next 3 weeks might be a firm plan. Some changes are allowed, but no major changes. And the next 3 months to 12 months would be a forecast. Through the production scheduling environment, you have to balance demand, but you also need to make sure the materials have arrived and you've got the capacity to produce the product. This is quite a challenging science. I had a client once who used to order everything to be delivered on the first day of the month. So the suppliers had no idea what order production would take place throughout the month. So they would deliver anything that they had ready on the first day of the month and continue to deliver through the rest of the month. The net result was, in the first week of the month, nothing got produced. because they would have bottles that didn't match ingredients, that didn't match labels, because they hadn't given an order of production to the client, to the supplier. They had only given their total demand for the month. They hadn't broken it into buckets. And that's where production scheduling is important. Production scheduling is about making sure you break it up into bite-sized chunks so that you're clear on what you're making each day in your production plan, so you've got the right materials at the right time for the right production. There are different kinds of production environment. So in some organizations, you might make to stock. This is typically for something where you have got a consistent, continuous demand. A good example of this might be manufacture of sugar, because sugar people are always going to be using in 5 kg, 10 kg, 30 kg bags. Whereas make to order would be for more customizable products. So when I make to order, I only make the stock that I have specific orders to. If I was a car manufacturer, this might be a strategy I employ. Because what it means is I only make the stock when I have an order for the vehicle. However, that means my lead time would be very, very long. So another option would be to assemble to order, to keep various components together, which I then assemble, and the final finishing products are made to order. So there are different structures. Make to order means I only make the product when there is a confirmed order. Assemble to order means I might keep subcomponents and assemble them when there is a confirmed order. Manufacturing to stock means I keep stock of the product in a warehouse all the time. And it doesn't mean to say one organization has to employ only one of these strategies. You might choose to do different strategies for different product groups. For example, your most economic vehicle might be made to stock, whereas your more specialized vehicles would be assembled to order. So, production control sits within the master production schedule. This is the place where we go in order to make sure that we know what is going on from a day-to-day, hour-to-hour basis. Part of production control is making sure we understand the material requirements, and this information has to be 100% accurate, because if there is an error in your material master, the inventory master records, the lead times, the quantities on hand, and the bill of material, you stand the chance of running out of materials. Tools such as material requirement planning will help you with this, but even better is solid relationships with your supplier. So some examples of where this might fail. I had a client who went and only updated their stock levels once a week. As a result, they overran on a certain component, used up more than they planned, and when it came time to produce the next order, there was no stock. So the system still showed the stock, but because the system was not up to date, it wasn't there. Other examples of this might be in terms of how we planned for a crisis a few years back, where we had a big issue with one of our suppliers for plastic bottles. And we ended up having daily meetings with the supplier so that we could make sure colors were planned and scheduled as per customer demand on a daily basis, because we were very, very behind on all our back orders. So relationships with suppliers are very, very important to that process. The bill of material. The bill of material is your recipe for your finished product. It provides a list of raw materials and quantities for each raw material, as well as information around things like lead times and economic order quantities. A typical example of a bill of material might be the recipe for a cake. Your cake will tell you that you need a kg of flour, half a cup of sugar, 3 eggs, and 2 bottles of milk, whatever it might be. That is the bill of material for making the cake. The question then becomes, what are the lead times and other information I need for planning the manufacture of that cake? Issuing of materials. Late issue of material results in production slowing down or even stopping. So we don't want late issues. However, early issues can clutter up the workstation. They can cause injury and damage to material. So it's really important, as I said earlier, you need to have the right raw material in the right place at the right time. Bringing stuff in late or early can have an impact on production. For example, when I ran a factory, we literally had capacity for 24 hours production of raw materials. And if a supplier over-delivered and delivered more than what we could hold, that stock would sit outside in the rain, in the elements, and get damaged. Huge issue from a point of view of managing stock and materials. The bill of resources is what you need in order to use the bill of materials. So for example, when I talk back to the cake, how many people do I need to make the cake? Well, I need one chef. What machinery? I need an oven. What tools? I need a cake tin. What PPE? I need oven gloves. So the bill of resources defines what other componentry or resources are required to make that cake. It will also tell me how long it will take to mix up the ingredients, what order I need to mix the ingredients, and it will tell me how long that cake needs to go into the oven for and what temperature. So it is a very clear guide to what I'm doing. So you've got the bill of material and the bill of resources, which guide you in the manufacture of your product. This one I think Ken spoke about quite a bit in the last presentation, so hopefully you guys remember the concept of capacity. But capacity required is how much capacity I need to produce my product in the period of time. Whereas capacity available is what is actually available. What is it that we are able to give in terms of capacity? Now, things that we need to think about when we talk about capacity is that sometimes the design capacity has never been achieved. So, for example, if you have a line that runs at 250 units a minute, but it's only ever achieved 200 units a minute, it is pointless planning at 250 units a minute. So although the specification states 250 units a minute, you will continually overpromise and underdeliver. It is far better to use the demonstrated capacity, the capacity that has been demonstrated through history, and that is calculated as the 200 units per minute. And by doing that, you are going to promise production at a rate that you have achieved in the past. However, this does impact utilization of your equipment and efficiency, because that will drop as a result of using the demonstrated capacity versus the design capacity. And it is the focus of the manufacturing engineers to continually improve utilization and efficiency. Rated capacity is the capacity the equipment is rated at, and productivity is how productive that equipment is. So there's various measures, and I'm not going to go into the detail, this workshop doesn't cover that, but should you have an interest in this and how to optimize your capacity utilization within your plant, I strongly recommend you consider digging further into the resources around manufacturing and resource control. So, how does it all fit together? This picture is a fantastic picture in that it shows you how the different pieces of the puzzle work. The first thing we should see is we start with the production schedule. So your master production schedule requires a rough cut capacity plan. So it's a rough plan of what you can produce on a weekly basis or a monthly basis in your plant. And it also looks at things like bottlenecks, essential materials, and other critical resources to make sure that you are planning to reality. Once we've got that rough plan, the next step is to go into a materials requirement plan. The materials requirement plan takes the information from the bill of material, the BOM, and the bill of resources, and makes sure that you have the right stuff required to produce this job. So it will go back to the various suppliers and order the various components and raw materials required to make sure you can produce. There is then a control process in terms of purchasing activity control, where the requirements are ordered, if required, and manage in terms of deliveries, as well as the production activity control, which is the management of the physical production of products in order to make sure you've got enough finished goods available to go into the warehouse or to your customers, depending on your strategy. This is a complex diagram, and I suspect you may need to take some time reflecting on it and thinking about it quite carefully, because it's important that in your production activity control, you understand all the different components that make up the planning process in a manufacturing environment. We do have different flows in terms of ways of running plants. Job shops are plants where you run specific jobs or specific processes. A good example of a job shop would be like a bicycle repair shop, where you have different bicycles with different componentry being brought in at different times, and each one is considered a job and you use a job card. A production line is an environment where you are continuously producing product on a production line at a particular rate, and it's a continuous process. We also have the push and the pull environments that are involved in the manufacturing of our stock. A push environment means that certain products are pushed through and you have to continuously manage your process all the time based on that push. A good example of that would be the sugar manufacturing industry. Because sugar cane only grows for certain periods of the year, from April through to November, and that is the season in which it can be manufactured, that is a push environment. So stock will be made in that period. Whereas for a pull environment will be where your customer determines your demand. And an example of this is your make to order or assemble to order, especially in the automotive industry, where you only build the vehicle or assemble the vehicle when there is a confirmed order from a customer, in order to minimize the stock value and to make sure there's less error in the stocks that you hold. Just in time is a critical process that is looked after and making sure that you have the right stock just in time. My brain. Okay. So from a just in time perspective, what you're trying to achieve here is minimum inventory in your process. So for example, within the Toyota industry, what would happen here is if I need to have a harness to go into a vehicle, which is all the electric wiring, I would send a job card in the morning to the supplier and say, I need 4 harnesses for 4 vehicles. The harness manufacturer will then make and assemble in that 4-hour period 4 harnesses for 4 vehicles, which will then be delivered to Toyota to go into the vehicle. When they supply that, what happens then is Toyota will then return with the next order for the next 4 hours. For example, they might say next order is 5 harnesses for the next 4 hours. And the harness manufacturer would make those and then supply them back to Toyota. This type of Kanban process, which is just-in-time manufacturing and making sure you only have the stock you need, has a massive positive impact on production. It also means that you've got less space constraints in the plant, because some of these componentries are huge and take up a lot of physical space. And therefore, it's important that you manage the stock very, very carefully. Sometimes this is also important in an environment where you have exceptionally expensive components or componentry. So for example, I worked with a client whose inventory was millions of rands, and it was a tiny little warehouse. But the stuff in terms of the carbon and graphic content of those products had huge monetary value. And in their case, it made business sense to keep the raw material uncut until such time as it was called for in the production process. That way there was minimum waste and minimum error in the material that was supplied to the factory, because things weren't made in advance. They were made as an order was required to the technical drawing. And all these processes require continuous improvement. And continuous improvement is a process of continuously monitoring your performance and your results to determine where your constraints are, where your challenges are. And by identifying your constraints or the issues that are taking place and tackling them one problem at a time, You apply a mindset of continuous improvement, because what happens is too many times we focus on all the problems at once, and as a result, we have no impact. But if we focus on one problem and fix it properly, then move on to the next, and the next, we are far better able to continuously improve the results and the performance within the business. So this is a key part of manufacturing and resource control. Lean thinking is also something that we need to think about, and I've mentioned the word waste a few times. Within the lean environment, there are a number of different wastes that have been identified, and each of these wastes are things that are really of huge value to you as an organization to identify. Because if you can figure out where the waste sits, you are then able to maximize the talent, the inventory, etc. in your organization. So I'm going to go through this one in a little bit more detail. The talent, underutilizing people's talents, skills, and knowledge. If you've got people in your plant or in your business who are sitting idle, who aren't maximizing their time, it's important to understand this, because if they're not adding value, you will waste money on salaries and wages. So it's important that in your talent process, you understand the utilization and the roles and responsibilities of your people to make sure that you are not underutilizing them, but also to make sure you're not overutilizing them so they become stressed and unproductive. So managing people's time is an important component of lean thinking. We've spoken a lot about inventory and not having excess products or materials being processed, so I'm going to move on. Unnecessary movement by people. This is an interesting one. So if you think about a changeover, for example, in many instances, the change parts are stored so far away, the tool room is so far away from the actual production area, that people end up moving unnecessarily far in order to get the job done. The workshop might be so far away from production that when a toolmaker comes, he comes all the way through, looks at the problem, walks all the way back to fetch his tools, and then walks all the way back to fix the problem. Those unnecessary movements need to be identified, and we need to think ahead of typical ways that we can solve that problem. In the example of the toolmaker, empowering the operator to identify the problem correctly so that he can phone the correct person with the correct information can solve the double motion in terms of him coming to help. The toolmaker then arrives with the tools required to fix the problem at hand. Waiting time is a big problem in many organizations. So I might finish making the tubes that I am producing, but then I have to wait and wait for space on the labeling machine, because the labeling machine is behind and it's operating at a pace that is far slower than the tube manufacturing machine. And this is a time of wasting, a type of waste, waiting. Waiting can also happen when, for example, you've got resources waiting for a person to send the next step in the process through to their process. An example here might be when we ran the personal products factory, the lotions process of making the lotion was far longer than the process of packing. So all the packaging was done, all the packing was done, but we were still waiting for the next batch of lotion. And as a result, operators would sit idle. Transportation or unnecessary movements of products and materials is also an example of a waste in your process. Transportation is something that's really important to understand, because if you are dispatching all your stock to one warehouse in one location and then sending it back to the manufacturing plant or back to the area where the manufacturing plant is, you could end up doing double movements or duplication of movement in your transport system. Another example might be if I stock up my Cape Town warehouse, that I've got no stock in my Maritzburg warehouse, and I have to move the stock then twice, once from the factory to Cape Town and once from Cape Town to Pietermaritzburg. I might end up doing unnecessary movements of products and material. In addition to the actual movement of material in terms of the cost of transport, is the cost of the defects. The defects are often caused by double handling in that transportation process, because the more times I handle a product, the more likely it is that I will damage it. Defects also occur in terms of the quality processes. So if your manufacturing process has quality issues where people are not paying correct attention, examples might be skew labels, incorrect dosing, under or overfill of product. These are all defects in your manufacturing process that can effectively cause rework. Overproduction. Overproduction is giving the customer more than he asked for. So if I want a plain bar of soap that cleans me, that's fine. Sell me that. Don't then go and get some fantastic new invention that I don't really need and add it to the soap. Focus on what it is the customer is looking for. For example, a good example here might be some of your cell phones. Many people, in terms of what they buy in a cell phone, that cell phone has far more functionality than what the average person uses. And the cost of that additional functionality might far outweigh the benefit that is achieved by selling that, and overproduction is occurring. So these are types of things that can be happening in your production process. Overprocessing, again, this is where you'll work to a higher quality than is required by the customer. So for example, overprocessing might be something like additional coats of paint that the customer cannot perceive or see. They don't know the difference between 2 coats and 3 coats of paint on certain products. That would be an example of overprocessing and putting more quality in than what is required by the customer. So those were the 8 wastes of lean. Lean is a very good philosophy to understand and spend some time unpacking, because what it does do is it helps you to understand where the waste is in your process, and through that you are able then to identify opportunities to improve and low-hanging fruit that can give you quick return on your investment. If I was running a small or medium-sized enterprise, this is definitely something I would want to focus on in my business. So what is quality? Quality is about ensuring consistent high levels of quality, continuously pursuing excellence, but it needs to be fit for purpose. There is no point in putting quality standards in place that the customer cannot perceive, the customer will not see. That is called overproduction or overprocessing. Continuous improvement is what you are doing to continually improve the quality of the product that you are purchasing. Quality at source. This is a philosophy that manufacturing environments have really started to drill down and drill home. So in the old school thinking, you would have quality control. Quality control means an external party comes into the manufacturing facility, and that external party sets a standard, enforces a standard, and becomes like a policeman to the process. This is all very well and good, but it adds an extra resource and it takes ownership and pride away from the person doing the work. Quality at source says, I must look after the quality of my work, me, myself, and I. That makes sure every person is responsible for their own work. But what we do is we have multiple quality checks throughout the entire process so that things don't get missed. And the processes are put in place to ensure that people take responsibility. And by doing that, there is a sense of teamwork, a sense of ownership that is driven through the discipline in the business. The quality at source is a phenomenal way of making sure that we are able to continually grow the team, to grow the organization, and to make sure we're not reliant on 1 or 2 individuals in the process. So I've just given you a snippet of what is included in the manufacturing and resource control module. Today's workshop is really just that. It is a snippet. The field of manufacturing and resource control is huge. This is just one element of the various supply chain offerings that SAPICS and BizCo are offering our specialist supply chain practitioners. You can register for these courses in the SAPICS website. And just to wrap up, every Thursday, the second Thursday of every month, we will be having these conversations. So it's important that you continually join these conversations. And our focus is on SMME development. So giving supply chain skills through to SMMEs. To really maximize the benefits of these webinars, please consider joining the SAPICS SMME membership, because you will get benefits in terms of discounted rates to training, discounted rates to conferences, plus their membership benefits around things like assessments to your organization, where we can give you discounted rates on specific assessments to assess your organization and its supply chain and help you to understand more. There's coaching and mentoring provided. So please take the time to learn more and visit the SAPICS website, www.sapics.org.za. The next webinar is on the 9th of, it's on the 9th of December, and we will be looking at a panel discussion around various topics that the SMMEs might benefit from. So please join us for that. Again, apologies for not being able to apologies for not being part of the original show due to load shedding, but hopefully this will provide you with enough information so that you are able to start learning more about manufacturing in the supply chain environment.